A primer to data structure by Sujit Das. The main layout of the presentation is introduction, data structure, abstract data types, stack, and queue. What is data? Data is simply a set of values. Data item is a single unit of the value. That is, data is a set. Then each element of the data is a data item. Group item, when the data item which are divided into sub items and they exhibit certain amount of characteristics within the sub items, and that's called group items. As employee name, their first name, middle name. So these data are related to each other. That way it is called a group item. Any real-time conceptual things that can be designated as an entity, something like temperature, velocity, any other object that can be entity. For example, student is an entity set, and each entry in the table is called the entity. Whole table called the entity set. So each attribute have their corresponding designated set of values, and the values have different types. So each types are called domains. Each attributes or each column is associated with a particular domain, like integer, text, decimal number, float. These are the domains. The information, sometimes when you process the data, the processed data is called information. For example, uh, date of temperature at a particular date is some data, but when you associate data, that data of a particular date, and we associate another attribute degree of Fahrenheit, then that becomes information. That is 30 degrees centigrade on 2nd March of 2021. That becomes an information. Data structure. Having data is not sufficient. We have to have some structure within the data. So why structure is so important? Because when you store the data, you have associated with it different kind of operation like searching, sorting, finding maximum and minimum. So such kind of operation will take varying amount of time depending upon the size of the data. So if we keep different structure within the data, then it becomes very efficient to access the data. So different way we can model the data depending on the relationship of the data, different structure that already existed in the data. We can explore other or more different types of structure within the data. So this is a classification of data structure. It is broadly defined, classified as primitive data structure and non-primitive data structure. Within primitive data structure, we have integer, real, character, and boolean. Integer is a complete number 1, 2, 3, 100, 200, minus 200, all are integers. Real numbers like floating point number, decimal number, like fractional numbers. They can be complete or fractional, both. Character like single alphabet character. Boolean 0 or true false 0 1, something like that. Non-primitive contains linear types and non-linear type data structure. Within linear data structure, arrays, linked list, stack, and queue. Arrays are the collection of data. Linked list are collection of data but not in a consecutive manner. Stack a different kind of structure which has a broad application and different domains. Queue is also a different kind of data structure which has also different kind of broadly in often existing process management, something like that. And process queue, for example, nonlinear data structure contains trees, graphs. Graphs are very useful data structure to represent complex structures in the data. Tree is also um, important data structure when data exhibit different hierarchical structure. We will explain it later. So as I told that array is a collection of data, but the type or domain of the data should be same, and it is stored in a contiguous manner, that is in a sequence. We have to store in a sequence one after another. So there are different way to index the data. That is, if we want to fetch any single data out of this set of data, then we have to use different kind of syntax. Suppose we can represent with subscript a1, a2, an, or we can use some parentheses. Within parentheses we mention the different index of the element, or we can use brackets. In bracket we have to mention the number. For example, ak called the subscripted variable. That's why the reason we use subscript here is called a subscripted variable. For example, a student in a class, 5-6 students, and we have to pick one student or indicate one student, that is June K. For that we have to use the name of the array student and different style of array indexing or the parenthesis or bracket, whatever we can use here. So this is another example of array. The first array is example of one-dimensional array, where the left column shows the index and the right column shows the value at that index. The middle array is called the two-dimensional array, and it is represented as a tabular format. The columns, and this is called the rows. So horizontal direction called the columns and vertical direction is called the rows. And any particular element is indexed using first row ID, and then column ID. Suppose we have to pick element 63, then you have to mention row ID 2 and the column ID 3. So if the name is A for this array, then we index the element 63 as A2, 3, and 2, 3 may be in parenthesis of index bracket. The right side is called the multi-dimensional array. Here we have shown only 3-dimensional array, but it can be extended to other higher dimension also. So each of the 3-dimension consists of the 2-dimensional array. This relation can go recursively to lower granular level also. That is, each 2-dimensional array divided into a 1-dimensional array. So 2-dimensional array is collection of 1-dimensional array, and 3-dimensional array collection of the 2-dimensional array. So in this way, 4-dimensional array is collection of 3-dimensional arrays. So there are recursive relation of higher dimension to lower dimension. So in this way, we represent 3-dimensional array. For indexing, we have to use 3 indexing keys. The first, for the which of the 2-dimensional matrix we are indicating to. Second, row and column index for that particular 2-dimensional matrix within the 3-dimensional matrix. So we need, if we want to indicate a 78, so suppose this brown dyed multi 2-dimensional array is first, then second, and the blue dyed is array 2-dimensional array is third array. So for to indicate 78, we need to write in a sequence like that: A 3 and row ID is 2, column ID 1, so A 3 2 1. So that is the way and index, different way of indexing one dimensional, two dimensional, three dimensional array. So even if we have advantage of representing data in tabular format, we have certain amount of limitations for array. The huge number of elements, allocation resources is not feasible, application of the arrays, data structure, tree, graph, facility, wastage of memory, increase complexity of the operation like shifting. Shifting is important operation for sorting of elements. So if we use array for sorting, then that will become a major problem for shifting. So to overcome such problem exist with array. A special type of data structure called linked list. In a linked list, elements do not reside in a sequence one after another. Rather, it resides or distributed throughout the memory, and they are linked together. So we can think of each element of a linked list consist of two items. One is data and another link. This link part is very important because it links to the next node in a sequence. So for example, the end of the screen we can see that there are three elements of linked list, first 10, 11 and 2. So to indicate the last node of the list element, we have to use special indicator called null. So null always indicates end of the list. Then another special kind of node we use which gives the starting of the list. We can name it as start. So if we put the different elements of the linked list in a tabular format, so we can show that how these particular elements are linked together. Suppose the first element 100 is linked to the third element. The second element linked to 5 element number 5, that is 56. Again in turn, the element number 5 is linked to the 4, element number 4, that is 78. So in this way, different elements are linked together, and we have marked as 0 to represent the end of the list. There again we have some limitation of linked list also. For simple operation we should not use linked list. And different kind of sorting applications, it becomes very complicated because we have to adjust the link with particular element and then again insert the elements, especially for single list. So when we can find different relationship among the data, especially in hierarchical relationship, then we represent those data in a tree format. Just for example, the employee has different hierarchical values. Then name can be divided into 3 parts, area divided into 3 parts, and the full representation can be presented, full arrangement can be represented in a tree format. Again, the graph can represent different complex structure like the route between different cities, countries, or important places. Different kind of operation that is applicable for data structure: traversing, searching. Traversing means just read each and every element of the list, that is list or tree or graph. That is traversing. Searching, when you have to find particular elements, or depending on different criteria, then for searching. When you add some new element or particular inserting, and when delete particular element is called deleting. Other operations like important operations, very popular operations on the list of elements like sorting, merging, hashing. Sorting means you have to put elements in a sequence like uh, increasing order or decreasing order. We call it sorting. When we combine two different lists, we call merging. And hashing is another way of structuring data that is totally mimic the operation of arrays, direct addressing, but each element may or may not have distinct index values. So when the two different elements do not has to distinct index, then we call it collision, and there are different way of maintaining or arrangement that avoid collision. When we represent different complex data with different structure and provide the operation using that structure, exist within the structure, then that type of arrangement is called the abstract data type. So linear list, tree. So if I create a data type as called linked list, then that would become a abstract data type. Matrix is also an abstract data type. Tree is also an abstract data type. Graph is also an abstract data type. It is a diagrammatic representation. Everything about abstract data type. So as you can see, there are different parts existing abstract data types. The application program or user program can access through on the interface the important data and data structures. Stack is a special kind of arrangement of data where insertion and deletion can take place, and that's the one end only. Like stack of books, stack of plates. If you want to remove the third book, you have to remove all the previous books, then you can remove the third book. And similarly, it is also applicable for the stack of plates. In the diagram, we can see the diagrammatic representation of stack. There are two well-defined operations applicable for stack is push, where the insert element, and delete element is called the pop. So in example, when you push the element, it goes to the current top element, top index. So initially is empty, though, and it inserted to index 1. Then if you want to push to element 2, then it go next top index, that is 2. So that's way. And if we want to delete 2 or 1, then both case we have to delete 2 also. So this is an algorithm for push and stop. There are different application of stack: postfix to infix, infix to postfix, postfix to expression evaluation, quick short algorithms, tower of Hanoi, recursion. There are varying other ways we can represent. Queue is another data structure where deletion and insertion take place at different ends. We can see the example how the operation is taking place. This algorithm. The algorithm for deletion. Different categories of queues are circular queue, DQ, priority queue.